Okay, so parabolas, but parabolas like part 2, a different way to look at parabolas. And it comes from a distance definition of parabolas, which is weird. You probably have not seen this before, but it's what leads to those equations that we'll use today. We won't derive them, but you might be able to make sense of them once we see them. Okay, the distance definition of a parabola is the set of all points equidistant. So there's our distance thing. Equa meaning equal, so equally distant from a fixed point, and that fixed point is called the focus. So one of the things it's equidistant from is a fixed point. The other thing, and a fixed line. And the fixed line is called the directrix. Funny name, directrix. So let's look at our picture and see if we can make sense of our picture based on that definition. So there's the focus, there's the directrix. We know what that point is. That's the vertex. That is right in between the two. So it's definitely equidistant from the focus and the directrix. And the distance we use there is p. And p will show up in the equation in a minute. Every other point is equidistant from the focus and the directrix. So you pick a point over here, and let's just say we'll call that D1, whatever distance that is. And then this distance to the directrix would also be D1. And you can do that with any point you like. Now, other points will have different distances. So if we pick something else, that's a different distance from D1, but it's still equidistant from the focus and directrix. And it's kind of complicated, but if you write an equation using the distance formula, saying D1 equals D2, you land with the equation for a parabola. We're not going to do that. Important points are these EOLR points. You don't even need to know what that stands for. They're the ones that are straight out from the focus. And they have we know that length. That length is 2 times p. So if p is vertex to focus, vertex to directrix, that's p. But then focus to these 2 side points is 2p. Okay. Well, we are now going to be able to deal with vertical and horizontal parabolas. So vertical meaning an up parabola or a down parabola. I would say those are the ones we're far more familiar with. Maybe we should have led with this. But a parabola is usually y equals x squared, something along those lines. So the squared term tells you which way it's going. And so this is where you sort of tie it to what you already know. If x is squared, that's kind of the normal parabola that you're used to, the up and down parabola. As opposed to a horizontal parabola, pointing left or pointing right, that feels sort of backwards, and the equation feels backwards if the y is squared. Okay, to graph, and then we'll just graph a bunch of them together. What do we usually start with when we graph parabolas? The vertex. Same thing here. We'll start with the vertex. It's usually pretty easy to find. The caution on the x thing is pretty easy because it's hk. On the y one, sometimes people get it backwards because they just put them in order instead of thinking about h is still with x, k is still with y. So be careful. It's still hk. It's still the thing with x, comma the thing with y. So start with the vertex. Then worry about direction. Meaning up and down versus left and right. Let's see. Up and down would be if the x term is squared. Left and right would be if the y term is squared. Again, that uses what you already know. The x squared, that's the normal parabola. That's the one you're used to. If y is squared, that feels weird, and it makes a weird parabola, a left and right parabola. Now, the up versus down, the left versus right, has to do with the sign of p. And it works just like you think it should work. If p is positive, it's up. If p is negative, it's down. Maybe I should have wrote these in a different order. What sign of p do you think makes it point to the left? Positive or negative?
Negative.
Negative. And if p is positive, it points to the right. So you put your vertex on the graph, and then you figure out, okay, which way is this thing going? And then you'll use p to find focus, directrix, so the point and the line, and then the EOLR. What does it stand for? This is where you get to giggle, because what it stands for is the ends of the lattice rectum. Giggle, giggle. Yes. Yeah. What? Wait. Mr. Wolf just said rectum? Yes. The ends of the lattice rectum. I'm sure rectum is Latin for something meaning the end. I don't know. So the ends of it are 2p away. All right, we needed some practice on this. So it's not hard, but we need to practice this. So you turn to the next page. And the next page is the homework, but we're going to do a few together.
There's a lot of them.
There are a lot of them. Once you get the hang of them, though, they go pretty quick, especially if they're in the right format. Now, some of them are not in the right format, so we'll worry about those later. But let's start with number 6. Number 6. You know, maybe we should read the directions first. Identify the vertex, focus, directrix, and direction of each graph, and then graph. Okay. So yeah, start with the vertex. So even though it's our very first one, I feel confident in jumping the popsicle sticks because I bet Ethan can tell us the vertex of number 6. Careful, the signs are changed. So if it's in there, if it's in parentheses with x, remember it shifts it left. So that's -2. And then it's parentheses with the 5, so it maybe feels like it's the opposite.
Okay, so it's
-2, 5.
Oh, yeah, because I can move it to the left.
Correct. Moves it to the left, moves it up. The vertex is also the thing that zeroes out the two sides. So like what makes it 0 equals 0, that's where you get your vertex. Okay, now this is a little bit new, but what the heck, Karis? Which way do we think this thing is? What's its orientation? Is it up and down or left and right? How did you know it was left and right? Because the y is squared. Good. Now this is showing extra stuff that you may not show once you get the hang of it, but we'll kind of walk through our entire thought process here. So left, right, its orientation is left or right because the y is squared. Jackson, let's be more specific. Is it opening to the left or is it opening to the right? How did you know that?
vertex?
Because P is positive. Because P is positive.
Oh.
Okay, we got to think back here for a second, because now I need to figure out what P is. So the 4P, this is where we got to be careful, is not on the squared side. The 4P is on the not squared side. So this is 4P, x plus 2, y minus 5 squared. So that coefficient is 4P. So yes, Ryan, go ahead. What does P equal? 1. Okay, so I know this is, a lot of times I'll sketch it as soon as I figure it out. This is a right pointing parabola. So it's probably good to do a quick little sketch as soon as you figure that out. That way once you get into the details, you don't accidentally draw it some other way. Because you get lost in figuring out P and thinking about all the things. Like, sketch a little picture so that you know at the end of this process it better look something like that. Okay, P is 1. So let's start labeling some things here. That's my vertex. That means, so if P is 1, the focus is only 1 away. And it did say to find these things or to label these things. So there's my focus is 1 away. It always wraps around the focus, so that helps you know where the focus is. So that would be at negative 1, 5. It is going to be kind of a smaller parabola. The directrix is 1 away on the other side. Be careful with the directrix. It's not a point on the other side. It's a line on the other side. You can dot it, you can make it solid, you can make it a highlighter, whatever you like. But that's my directrix. What's the equation of that line?
X equals -3.
Very nice. X equals -3. And then the only 2 points you have to graph, I guess this is one way it's easier than the other graphing, but
Oh, the ones that are
are the ones that are 2P away at the focus.
Oh, I like that.
The ends of the lattice rectum. Get to say it again. So 2P away from the focus would be right there and right there. And now we've set our parabola. We've graphed it enough. So there's our parabola. Graphed using a different process than we've used before. But still using those same ideas, right? If x is squared, it's up and down. If y is squared, it's left and right. The new stuff is the 4P thing. How about 4? I say why you want to do 3 or 5. Yeah. Because those have the y squared in them. So yeah, let's do 5. Let's do 5. Mix it up here. So let's pick on some people here. So Ellen, what's the vertex of that thing?
-5, 2.
Good.
Why would it be negative if
Well, because you could easily put parentheses around there. Or you can, again, just think, well, what would zero that thing out? Because the vertex is kind of the 0, 0 point. So maybe that's even a better way to say it. What would make it be 0, 0? What would make this equation be 0 equals 0? Negative 5, 2 would make that work. Adeline, what direction is this thing going? And you can give me specific, or you can just tell me left, right, or up, down. Let me back up. Which term is squared? Okay. And for our normal parabolas, what we think of as normal parabolas, usually x is squared. So if y is squared, what does that mean? Perfect. Y squared tells me that this is a left-right parabola. Jack, let's be a little more specific.
To the right?
It is to the right. How'd you know that?
Yeah, there's not a negative.
There's not a negative. That's a good way to phrase it. I'm still going to say P is positive. There's still a P there. It doesn't like it's not there. Like, what is the P? Well, what would P be? It's not 0. Again, for a while you're going to write this out, and that's okay.
Wait, we always said it equals 4p?
4p is the constant in front of the non-squared term. 4p is the constant in front of the non-squared term.
So it's just always there.
Yeah, and so there's sort of not one there, but it's like if I ask you, if we had 5x squared plus x plus 7, and I said, what's the coefficient of x, what would you say?
5.
What's the coefficient of x? 1. And then I would say, well, yeah, but there's not a 1 there. And you're like, well, there's not, but there kind of is. Same thing here. What's the coefficient in front of the x plus 5? 1. I mean, it's not written out, but there's a 1 there. So if 4p equals 1,
So wait, 1/4? How do you do 1/4 away from the vertex?
very carefully. I mean, it's a good question. Because, yeah, this is going to be annoying. So
He's always equal to the number that's in front of the x
of the non-square term.
non-squared.
4p is the number in front of the not squared term. So one term gets the squared, the other term gets the 4p. Maybe that's the way to say it. Keep things even.
And the parentheses weren't there originally. Does that change?
It didn't really change anything. We put them there to make it look more like the format. So vertex, we got that. P is 1/4. So I need to go 1/4. This is why I like drawing I've lost track of what I'm doing here. I got to wrap around my focus. So my focus is going to be 1/4. This is super annoying.
And they're both 1/4 or 1/2 more.
So they'll be 1/2 away for my EOLR. But let me write the coordinates of the focus.
It's 4.75.
4.75 would work? Yeah?
Negative 19.
Or negative 19/4. Or negative, you can even go, we usually don't like mixed fractions, but sometimes it's a good use for it right there. Negative 4 3/4, comma 2. 4.75 is fine, 19/4 is fine. All those are equivalent. The directrix is x equals negative 5.25. So now I'm mixing fractions and decimals, but that's okay. And then, I need to go 1/2 away, because I need to go 2p away on either side. So 2p is 1/2. So from the focus, I need to go up 1/2 and down 1/2. Yeah, I'm glad we picked that one, because that's annoying. Because if p is 1/4, 2 times 1/4 gets us 1/2. Number 4. What makes number 4 different than 5 and 6? X is squared. Yeah, that's right. In your mind, you're thinking that's normal. P is negative. Okay. So what's that mean? It's down. Okay. We've done a couple of these, so some of you are going to jump straight to that right away. You're going to say, all right, x is squared. That means it's up and down, but there's a negative, so that means it's down. When you make that realization, strongly suggest you draw a little downward parabola right there. Because now you can say down, that's fine. Now we're going to dive into the details of where the pieces are, but we don't want to lose sight of, like, this is a downward parabola. Rena, how about the vertex for this thing? Good. Negative 4, 2. Again, you're thinking, what would zero out my parabola? Because that vertex is sort of the 0 point. So negative 4, 2 would be the vertex. Why do I want to do this one, Ryan? Okay. The coefficient on the non-squared term is equal to 4p. And the fact that p is negative is what makes it down. Is one way to phrase that. So the negative sign, you knew right away that flips things over, so it's down. A little more technical way to say it is that since p is negative, that's what makes it point down. Let's see, negative 4, 2. There's my vertex. My focus is a half away. A half away in which direction? Down, because I've got to wrap around the focus. In fact, this is overkill, but some people would put like all the pieces on their little picture. So the focus is half down. So negative 4, and then up 1.5. Again, 3 halves, 1.5, 1.5, any of those things. The directrix is on the other side. Careful, half away still. That's a y equals line because it's horizontal. We went up a half from 2. So that put us at 2.5. And then how far away are the EOLR from the focus? Well, I guess you could say negative 1, but it doesn't matter because you're going on either side. So 1 unit away, because 2 times 1/2 is 1. So 1 away, 1 away. That's what helps set the width of this thing. No, but since you want to do something a little more difficult, that's how I interpret that question, let's turn the page and give Jack a challenge, because he's already bored with those simple ones. Like, let's do something more. That's how I interpreted that question. Like, Mr. Wolf, this is too easy. Give me more. Challenge me. So because of Jack, we will continue on and do more problems.
You're welcome. Hey, it's more of the homework.
It is more of the homework. Write the equation of the parabola in standard form. It's like, wait a minute. None of those are in standard form. Find the and then do all the same things we just did. So I've got to get it into standard form.
Can we change the standard?
We're going to do number 8. So what was the question?
We should change the standard.
So standard form is where you get, where you have the squared thing equals the not squared thing, or equals 4p times the not squared thing. Yep. Again, so one side gets the squared, and one side gets the p, or the 4p.
Some of these standard forms are bad.
That's true. That's fair.
Yes, they should just have one overarching standard. They should just be whatever.
Standard form 1, standard form 2. There should be the 3.
So what should I do on number 8 to make it into standard form? Make it into this standard form.
Probably move the y over. The y has to be 6 squared. Oh yeah. Or the y is already.
So yeah, I need to move one of them over, and I want the squared term to be positive, because the p can be positive or negative. That'll change the direction. So let's move the 6x over. So it's y squared equals negative 6x.
Is that the whole thing?
That's the whole thing, although that makes it tricky to figure out what the vertex is. So it's 0, 0. Now, if you really need to It's a little bit overkill, but if you want to really expand it out, you could put minus zeros in there. It's not necessary, but that helps you see that, yes, the vertex is at 0, 0.
So P is 4 divided by
I'm going to back up from what you just said. I think you were right. 4p is negative 6. So you were right. You said p is negative 6 over 4, which reduces to negative 3 halves. And since we're using that on the graph, I mean, that's right, but it might be better to phrase that as negative 1.5, right? When we start graphing things, 3 halves is not as helpful as 1.5.
Since there's no numbers on the graph, could each square be half rather than 1 just to make...
Oh, you're going next level on me.
Then everything's on line.
Then everything's on the...
But wouldn't you have to say that?
You would have to indicate that somehow, but yes.
Wait, what are we indicating?
So Jack wants to change the grid. It's not labeled, so he's free to do this. From making each square worth 1 to making each square worth a half.
That's smart.
I like that. So I do need to indicate that somehow.
I'm just going to write off the side.
You can write off each square equals a half, or you could sort of label tell me it's a 5 by 5, not a 10 by 10. Well, I guess it is. You can label a point, or maybe it's easier to just say each square equals a half. All right, that doesn't change where the vertex is, but it does make going up 1.5 or down. Wait a minute, that's why I'm confused. What direction is this thing going before I start?
He is negative. Yeah. Oh,
Wait,
no, left. Left.
Yeah, so left.
The y is squared, so it's left or right, but then p is negative, so it's left. And maybe we, again, probably should have figured that out earlier so that I can put all the stuff in the right spots. Okay, so the focus is negative 1.5 away. So negative 1.5 comma 0. The directrix is 1.5 away, but 1.5 away on the other side. X equals 1.5. And my E, how far away are the EOLR from the 3?
So 6 boxes.
So 6 boxes, that's right.
There we go. It's not a 10.
This was harder to see on the earlier ones, but you end up making 2 squares because of all the symmetry stuff. So like that, you don't have to locate that, but if that sort of helps you visualize that you're on the right track here. Yeah, I hit that one pretty well. I've dedicated my life to drawing the perfect parabola. All right, but
2 squares? No, that's right.
well, it's 1 rectangle or 2 squares.
Oh, okay. That makes sense.
Yeah.
I only saw the rectangle.
Just be careful. Don't make it 1 giant square. It's 1 giant rectangle made up of 2 squares.
That was hard.
Yeah, that wasn't even the worst one.
Yeah, this is not easy.
Let's go to 13. Aren't you glad Jack wanted us to do these?
This is the first day. Yeah, well, we would have had to figure it out.
I think you wouldn't have been able to do it on your own. So, of course, we were always going to do
I
this.
think we move over the...
Oh, we still want to hit on draft.
But yeah, we still want to blame Jack for it. So, okay, standard form. Maybe it helps to see what we're aiming for. I want something squared on the left and 4p times the other thing on the right.
Wait, why is... Oh, we're in third.
I'm sorry, flip to 13.
X minus 6.
So, which variable is going to end up on the left and which variable is going to end up on the right?
X on the left.
X on the left because there's a squared term.
But there's also
X squared minus 6,000.
when we factor that next.
So x squared minus 6x on one side. I moved the 10y and the 1 to the other side. And I wrote that very carefully and intentionally. That might give you a hint on what...
Are we going to complete the square?
Yes, sir. We love complete the square.
Wait, what happened with 4p?
The 4p shows up at the very end. Whatever is in front, that'll be what 4p is. So I don't know that yet. I suspect it's going to be that 10, but I don't really know that yet.
Half it squared.
Half it squared added on which...
Both. Or it's the 6.
Yeah, add it.
Wait, complete the...
Square.
Add it to
So all the squared side.
So on the squared side.
Oh, don't you add it to both?
But we'll definitely have to add it to both, yeah.
So plus 9.
So let's slow down. b over 2 is negative 3. That's the half it part. Square it, we get 9. So plus 9 makes that a perfect square. Like that. But I can't just stick a plus 9 on a problem. That's not legal.
You gotta do
I either need to minus 9 on the same side, or better yet for this one, add 9 to the other side. Okay, so on the left, x minus 3 squared. On the right, negative 10y plus 10. Or better yet, because I know I need something factored out, I need the 4p thing out front. So it's not really wrong, it just doesn't look like it's in the right form yet. So let's factor out that negative 10, and that leaves y minus 1.
I know we still have to graph.
And then 4p.
And then now we get to do all the other things. Yeah, well, we're going out of order here. But yes, 4p is now negative 10. Let's back up. Is this thing up, down, left, or right?
Up, down.
Up or down?
Down.
Up, down.
But it is down.
Yes, it's one of those. How did you know it was up or down? Let's just back it. X is squared.
That's what I thought you were going to say.
X is squared means we are up and down. Up or down. Why do you think it's down, Cooper?
Because the 10 is negative.
The 10 is negative.
I agree with Cooper.
So, again, when you figure that out, I really like drawing a little bitty down parabola because there's lots of details left to come, but I better end up with a downward-facing parabola. Lovely when it's not a multiple of 4 there. Okay, so now back to our regularly scheduled programming here. Kennedy, how about what's the vertex for this one? 3, 1. Very nice. Over 3, up 1. We are going to get halves, but I don't...
You don't want to be special?
I don't want to be special. Special by, you mean changing the...
Yeah.
You can change the scale again if you see those halves and you're like, I don't want to deal with it. That's fine.
It doesn't fit.
I don't know that it would fit. If 4p is negative 10, then that means p is equal to negative 5 halves,
2.5.
which is not wrong. It's definitely right. But when it comes to graphing, 5 halves doesn't do me much good. I'd rather call it 2.5.
That's all.
Okay, so how do I get to the focus from the vertex? Which way am I going to go? Down 2.5. So my focus is over 3 and then negative 1.5 because it went down 2.5 from the vertex. My directrix is on the other side, so up 2.5.
Y
So y equals 3.5. Yeah, because we went up 2.5 from 1. Okay, my EOLR are 2p away, so 5 on either side. I'm not really worried about the negative. I guess you could say it switches which one's where, but it doesn't matter. 5 on either side. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Should have brought my reading glasses today. It's a little Little graphs, hard on the old eyes.
That's my Christmas card yet.
Okay, so that was complete the square.
You gotta send your letter to Santa soon.
I know. Santa's gonna come get that me soon. $20 yet.
All right, so your assignment is the rest of the worksheet.
When's it end?
It ends at 14. The good news is there's no new concepts tomorrow. Tomorrow we just give you sort of random pieces of information and you figure out the equation. So, do we need to look at number 3? Backing up to number 3 now? What's the vertex on number 3? 5, 0? Which way is it going? P is, careful, 4P is negative 4, so P is negative 1. And then you're off and running from there, I think, I hope.